Alright, welcome to another PowerPoint 1.5. Big section on stoichiometry. So we'll go through a lot of calculations today. So you'll make sure you pause or rewind if you need any more clarification or come back to something. Very important section in later chemistry as well. So we have a reaction, and remember you have reactants and products and a yield sign. And you gotta make sure we balance equations. So balancing is always important because we need to know the stoichiometry of it. We need to know the ratios. We need to know the recipe. So here's your balance equation. It's 1, 3, 2, 3. So 1 molecule of iron 3 oxide, rust. We'll add 3 molecules of carbon monoxide and we'll make 2 atoms of Fe and 3 molecules of carbon dioxide. So, what do these coefficients tell you for the reactions? Well, it tells you a recipe. So that means if I have 1 molecule of iron oxide, it will react with 3 molecules of carbon monoxide. It will make 2 atoms of Fe and make 3 molecules of carbon dioxide. So that ratio is always going to be the same. And it's a ratio. It's not always going to be 1, 3, 2, 3 amount, but the ratio is always going to be 3 to 1, 2 to 3, 3 to 2, stuff like that. So the balanced chemical equation shows us the ratio of moles, and that's what stoichiometry is. It's actual ratios. So we use stoichiometry 2 ways. One is to figure out the actual amount we need for the reaction, so there's no waste, because we don't want to be wasting our chemicals around, so we need to calculate how much we actually need. The other way is to figure out how much product we are going to make. This helps us determine how well the lab went. If you are supposed to make 2 grams, you only got 1 gram out, that's only 50% obtained. So you want to make sure you do the calculation right so your lab is done correctly. So, quick review on reading the balance equation. What is the mole ratio between iron 3 oxide and carbon monoxide? You have 1 mole of Fe2O3 and 3 moles of carbon monoxide. There's a 1 in front of the rust because there's no number in front of it, so we just assume it's 1, and then everything else is the coefficient. What's the mole ratio of iron 3 oxide and carbon dioxide? Same thing, 1 to 3. So you gotta make sure if there's no number there, it's a 1. Well, it is a number, but we don't write 1. So how do we use these ratios? Well, the ratios are used to convert, so dA, from one compound to another compound. So we can go from anything in that balance equation to another substance in that balance equation from using the ratios. So that makes sure you gotta get the moles. Always gonna go to mole land. So here's a kind of few things problems that you'll see. If you're just going from moles to moles, then you just use the coefficients. Anytime you're dealing with mass, you gotta use molar mass. So you will be using the coefficients and the molar mass in these 2 examples. Alright, moles to moles. So pretty simple problem. You want to find the moles of iron from 2.3 moles of carbon monoxide. So you start with your given, 2.34 moles. And you want to use the coefficients 2 to 3. 2 moles of Fe to 3 moles of carbon monoxide. And the moles cancel out. Multiply and divide, get 1.56 moles of Fe. Alright, moles to mass. So we start with the same problem, but ask for the grams of Fe. So you start with the same way we did. You have 2.34 moles of carbon monoxide. Use the coefficients to get to iron. Now we want the mass, because the mass means a lot more to me than moles. I can't measure moles out on the scale. I can measure mass out. So I need to know the molar mass of Fe. In 1 mole of Fe, there's 55.845 grams of iron. That comes from the periodic table. You gotta cancel out moles. You can multiply and divide. You get 87.1 grams of Fe. So if I did this in the lab, I would assume I would get 87 grams of iron. Alright, the big one. Mass to moles to mass. So this deals with all the converting. So you're given mass, grams, of carbon monoxide, and you want to find how many grams of Fe will you be producing. So you start with your given, 45.6 grams, and we have to go through mole land, always through mole land. So you gotta get to moles. The only way to get to moles for mass is using molar mass. And the molar mass of carbon monoxide is about 28, 12, and 16 for oxygen. And that's 1 mole of carbon monoxide. Grams cancel. So now we have carbon monoxide, we want to get to iron. So anytime you're going from one compound to another compound, you need to use the coefficients. In this case, again, 2 to 3. And lastly, moles are great, but we need to get to mass. So you gotta use the molar mass again, in this case for iron, and it is 55.845 grams of Fe. Moles cancel, multiply everything on top, divide everything on the bottom, and you get 60.6 grams of Fe. Alright, quick review. Stoic rules. First, you gotta write the chemical equation. You gotta make sure it's balanced. Without the balanced equation, then the ratios are all 1 to 1, which won't be true always. So you gotta make sure you balance the chemical equation. You gotta set up your dA from the given information. So whatever given you have, you gotta start with it. And the last thing is do it. Rock out with a stoic. Make sure you use the periodic table for balanced equations. Make sure you use the ratios to go from one compound to another compound. And just do it. Alright. Practice. So here we have to look for the grams of potassium chloride from the grams of potassium chlorate. So in this reaction, potassium chlorate, it's a solid, it's being decomposed, so it's heated to break apart into 2 compounds, potassium chloride and oxygen gas. Start with your given, 6.89 grams, and we need to get to moles. So you gotta find the molar mass of KClO3. So one chlorine, 1 potassium, and 3 oxygens. And it comes out to be 122.55, and that's 1 mole of potassium chlorate. Grams cancel. So that's great. Now we have moles. We're in mole land, but we want to take a transfer. We're in potassium chlorate. We want to transfer to potassium chloride. Looking at the coefficients, the 2 to 2 ratio, or 1 to 1. So 2 moles of KCl is 2 moles of KClO3. Moles of KClO3 cancel, and now we have KCl. They're like, great, now we want to go back to Massville, so we need to use the molar mass of KCl. Potassium chlorine, 74.55 is 1 mole. Use the periodic table. Moles cancel. Multiply everything across. Divide by the bottom. You get 4.19 grams of KCl. Okay. So that is part 1. So that's going to be broken apart, and we'll get into part 2 next.